vectors. In the diagram, OABCD is a pyramid, vertex D, horizontal base, OABC is a square, side 4, so this is 4, edge OD is vertical, OD is 4, this is 4, unit vectors I, J, K in the direction, and dn equals 3nc, so this ratio is 3:1, which means, of course, if we split here, this length is 3, this length is 1, this length is 3, this length is 1 actually. Alright, now find a vector equation through m and n. So to find the line equation through m and n, we need the coordinates of m and the coordinates of n. And to find the coordinates of m, OM is from O to m. We can go from O to A and then A to m. So from O to m, that is 4i. A to m, that is, the length is 2 because m is the midpoint in the middle, so this is 2, and the direction is j, so 2j. So in column notation, this is ijk 420. There's nothing, means we have actually 0k here. And for the n, the coordinates of n, so from O to n, we can just go from O to this point, and we're just going to call it x. And again, this distance is 3 in j direction, 3j. And this is 1 in k direction, 1k. So there is no I component. Component, yeah. So 0, 3, 1 is the column factor for the coordinates of n, or the position factor on. Now to find the line equation, we can use the point m or n. So here we are using the point m, and for the direction we can use mn or nm. So for the coordinates of m, previously we know it's 420, and for the mn means the coordinates of n minus the coordinates of m. So we subtract 0 minus 4, 3 minus 2, 1 minus 0, we get this line direction factor. So again, we can use ON instead, and we can use NM instead, and it's also correct. Show that the perpendicular length O to MN. So we start by drawing a sketch. This is, say, the line equation, and let's say this is point O, and the foot of perpendicular, let's say it's point P. We don't know the coordinates yet, we're going to call it XYZ, and it's perpendicular, so the vector OP dot the line direction equals 0. The vector OP is just P minus O, so X minus 0, Y minus 0, Z minus 0, basically XYZ. The line direction is this vector. The dot product is X times minus 4, minus 4X, Y times 1, just Y, Z times 1, just Z. So you see we have 3 unknowns in this equation. We cannot do anything about it. So we're going to use the fact that this point P is on the green line, which means it satisfies the line equation, which means we can replace this X with 4 minus 4 lambda, just like this. And we can replace the Y with 2 plus lambda, just like this. And we can replace the Z with 0 plus 1 lambda, or simply lambda. So now everything's in lambda. We have only one unknown. We can find the lambda. This is minus 16, and this is plus 16 lambda. So after we simplify, 16 plus lambda, 18 lambda. Minus 16 plus 2 is minus 14. Add 14 to both sides, divide both sides by 18, we get the value of lambda. So now to find the coordinates of P, or the position factor OP, it's on the line. We use the line equation. The lambda value is 7/9 for this point. So use the calculator. 4 plus 7/9 times minus 4, that's going to be 8/9. 2 plus 7 over 9 times 1, that's going to be 25 over 9, and 0 plus 7 over 9 times 1, that's just 7 over 9. Remember, we're looking for the distance, so actually we are looking for the magnitude here. To find the magnitude, we use the square root of the sum of the square of each component, so 8 over 9, 25 over 9, 7 over 9, square everything and add, use the calculator, we get what we need to prove. Alright, I'll see you again next time.